Hi, everyone. This is Aaron Larson, executive editor of Power Magazine, and you're listening to the Power Podcast. On today's episode, I'm joined by Clay Sell. Clay is the CEO of X Energy. So, Clay, I appreciate you coming on the program. Please tell a little bit about yourself, your background, and X Energy.
Aaron, it's great to be with you. Thanks for having me on. I've been the chief executive at X Energy for about 6 years. X Energy is a developer of high temperature gas cooled reactors using triso fuel in a pebble form. We are a vendor of that particular technology, and we are also a manufacturer of the fuel that we use in our reactors. And I'm pleased to be here to talk more about it.
Nuclear power is such a trending topic. We hear a lot about Meta and Amazon and all these tech companies, Microsoft as well, getting into nuclear power and wanting to deploy some of these reactors. Can you talk a little bit about your technology specifically? What is X Energy's current situation? Where does the technology stand in terms of deployment readiness? And where are you in the regulatory approval process?
Aaron, I think one of the reasons nuclear power has been trending, to use your word, is because, over the last several years, there has increasingly become a broad recognition that there is no way our economy can achieve its aspirations in both meeting energy demand and cleaning up the way that we do it without clean, firm, 24/7 carbon-free sources of power. And that recognition has led both the center left, the center right, communities, and policy experts all to come to the conclusion that it's time for a fresh rethink on nuclear power and the role that it's going to play going forward. So we at X Energy saw this day coming. I'm proud to say, almost 15 years ago, the company was founded by an entrepreneur named Cam Gaffarian, and he really saw this moment in time coming where energy demand and the need to decarbonize and clean up the way we provide power would force a reconsideration of nuclear power. So we brought a technology to the U.S. marketplace that has a pretty long and established record of success. High temperature gas cooled reactors. So that's the type of technology that we are developing, have been built in the United States, in the United Kingdom, in Japan, in Germany. This particular technology was first really brought online in Germany, and it's also been brought online in China. So there's an established operational pedigree for high temperature gas cooled reactors using a pebble fuel form, and we're really pleased to be in the position to be one of the first SMR technologies deployed in the United States.
Listeners will, of course, know my background, but I spent 13 years in the nuclear Navy and worked at the Quad Cities plant for several years. So I am a big proponent of nuclear power. And I remember way back when I was in the early years of my Navy career, hearing about pebble bed modular reactors. And this was back in the early 90s. And thinking, wow, this is new technology that's really going to take the world by storm. And now, we're almost 35 years later. What took so long for this to really gain momentum? Can you talk about that at all?
Well, the United States basically decided to stop building new nuclear power plants in the late 80s, early 90s. And so that's the first thing that happened. The US made a decision to stop. Now, the world didn't stop. And most notably, China and Russia continued to build and develop their technologies at a fairly furious pace and have now achieved a dominant position globally in terms of the number of new units that are being deployed today. But as politics around nuclear power and the policy environment around nuclear power. And again, as the notion that we have to have clean 24/7 solutions to power a growing US economy and decarbonize, you know, it forced a reconsideration of technologies. And so, we are getting back to the market as quickly as we can. Again, we started this company 15 years ago. Our first project is going to be deployed in a public-private partnership with the US government and Dow Inc., the large chemical manufacturer, at a site southwest of Houston, Texas, that will come online around the end of this decade. And we'll make our first license application to the NRC in support of that project, just after the first of the year. And we see the opportunity for rapid deployment thereafter, particularly with the support of one of our biggest announced customers, Amazon, which we announced just last month.
Can you talk a little bit about the steps that you're most focused on today to make that happen, to get that Dow chemical plant built and to get Amazon's plant built and operating as soon as possible? What do you need to do today to make that happen in the years to come?
We are in the final stages of our design effort. We will then take that design and it will be submitted to the Nuclear Regulatory Commission in terms of a construction permit application, which we expect to receive approval on that application in the early 27 timeframe, which will then allow us to start construction. We anticipate construction on the plant to be about a 3 to 3.5 year process, which will then bring it online in the early 2030s. Our focus is really on this first project, and it's a really important project because it's really a unique public-private partnership between the U.S. government that is providing half of all of the capital required, and Dow Inc. That will own and ultimately operate the plant and own that asset for the long term, and X-Energy, which has the role of providing the technology and manufacturing the fuel that will be used in that plant. So our focus today is on design and licensing activities and in the construction of our commercial fuel facility that's underway now in Oak Ridge, Tennessee.
There are, of course, many other companies that are doing similar work with small modular reactors, and I could name, TerraPower and GE Hitachi and Westinghouse and others. But what specific advantages do you feel your technology, the high temperature gas cooled reactor, offers compared to these other technologies and other more traditional nuclear designs for, large scale power production?
The most significant advantages that we have over large-scale traditional nuclear power plants is the evolution of our technology, our safety case, and just the smaller, more simplified designs that can be built with much less time and much less money. There are other aspects that are kind of unique to our next generation design. Again, we're a high temperature gas cooled reactor using a TRISO fuel form, that's ceramic encapsulated fuel in a round pebble that flows through the reactor like gumballs through a gumball machine. And the things that really make us unique are the intrinsic safety of our design. So what does that mean when I say intrinsic safety? That means this is a plant that cannot melt down under any scenario that one could imagine affecting the plant. So that extraordinary safety case allows us to operate on a very small footprint. It allows us to design a unit that has a much simplified design with less, fewer subsystems and components, less concrete, less steel, less equipment to go around it. It allows us to produce steam that is very high temperature, high quality steam, which is attractive for manufacturers like Dow that need steam as an input to their manufacturing process. The four units of our design give a very high degree of reliability. So in the case of Dow, we're able to provide 99.999% reliability in steam production. And then there are other aspects of our design which allow us to support load following, allow us to support online refueling, which gives a very high availability factor for our design. All of this is being delivered in a small modular package. So when you think of the benefits of SMRs, we think about components that are small enough to be manufactured in a quality controlled factory environment and then shipped to the site for assembly in a period that can be measured in months rather than a conventional stick-built design that is manufactured over years and in some cases decades. So there's lots of innovation and lots of benefits that we're bringing to the marketplace with this design. And we still have years of operational pedigree to support what we're doing.
You mentioned how the pebbles come in kind of like a gumball machine and are fed through. Can you talk a little bit more about the technology and how it works and why that is significant to the design?
Yeah, let me do it by comparing it with existing reactors. And I think it's important to note that our reactor technology is orders of magnitude safer than any nuclear reactor technology that's been deployed at scale. But having said that, I think it's important to note that nuclear power today, even as it is, the conventional plants are the safest form of generation that's ever been deployed at scale around the globe. I mean, these are extraordinarily safe plants. But the existing nuclear reactors can, in theory, melt down. And they don't melt down and they won't melt down because engineers have designed redundant safety systems that they've put around these plants to ensure that they remain safe under all circumstances. So we took a different approach at X Energy and we said, what if we start with a reactor that can't melt down, where it's physically impossible for this reactor to melt down? And that starts with our fuel form. And our fuel form has enriched uranium that's encapsulated in ceramic and graphite materials that cannot melt at any scenario. So we start with an incredibly robust fuel form that can melt down and retains all of the waste products that are produced during burnup. And then we put this robust fuel in a reactor that has design attributes to it that ensure that it's intrinsically safe. We load the reactor column with thousands of pebbles, and then we initiate the chain reaction, which creates heat. And then we evacuate the heat out of the reactor with helium gas, which is a very efficient heat transfer fluid. And then we use that hot helium gas, we run it through a heat exchanger, and we produce very high temperature steam for either industrial uses or to create electricity. And the pebbles in the reactor flow continuously through the reactor. And so that provides a very high availability factor. So for example, Aaron, light water reactors, and a typical light water reactor has to be shut down every 18 to 24 months to shift around the fuel bundles and replace spent fuel bundles with fresh fuel bundles. And in our case, that happens on a continuous basis with the flow of the pebbles through our reactor core.
Yeah, I think that's a really neat process. I mean, obviously, you still need to shut down for maintenance on various pieces of equipment, but you don't have a specific 18 to 24-month refueling period. It's just a continuous process.
That's right.
And how do you see your reactors fitting into the broader energy transition that's taking place? I know some people have talked about replacing coal plants with nuclear plants, for example. Is that something that you could see happening in the future?
It is. And, again, a helpful way to think about this new technology is to compare it to existing nuclear technology. Existing nuclear technology are large plants, typically in excess of 1,000 megawatts in size. They're large central stations that have a huge emergency planning zone around them. And they're really only optimized for producing electricity to feed into a centralized grid. But with our technology, it's smaller. It can produce electricity, but it can also produce steam. And so that presents a whole host of new applications of greater functionality to address the energy transition. And perhaps the most notable opportunity is the one that is represented in our partnership with Dow. This is an opportunity to use nuclear generated steam, carbon free steam, to help decarbonize the process of making plastics. And there are many opportunities to use our technology to decarbonize industrial processes that use steam. About 20% of global carbon emissions, I'll say this again, about 20% of global carbon emissions come from the industrial heat sector. And virtually all of that industrial heat today is produced by burning hydrocarbons, coal and natural gas, and emitting carbon into the atmosphere. So with our technology, we have the opportunity to replace hydrocarbons and use nuclear generated carbon free steam to dramatically decarbonize these so-called hard to decarbonize sectors like industrial heat. But also because of our safety case, we operate from a very small footprint. So Aaron, you mentioned the possibility of replacing coal plants. That's something that our technology is uniquely suited for. A lot of old coal plants that were built in the last 50 to 75 years operate on relatively small footprints, but they have an engaged workforce. They have takeaway capacity in terms of transmission, but they just don't have a lot of room for a traditional nuclear plant. But because a typical X energy plant will only cover less than 30 acres, it's easy to imagine how we can come into a community, site our plant in an area right next to the old coal plant, utilize the workforce, utilize the transmission takeaway capacity to provide life to a community that for decades built it on top of the jobs and economic output of a coal plant. We see a dramatic opportunity to reinvigorate local economies with a new generation source, in this case, advanced nuclear power plants.
In our opening, we didn't really speak about your previous history, but I know you served as a Deputy Secretary of Energy for a period. How has that experience helped inform your approach to leading X Energy?
That's true. In a previous life, it's hard to imagine that it was 20 years ago now. I was appointed to the number two position at the Department of Energy in the second term of the George W. Bush administration. And so I've had an extensive policy background in all things related to the energy sector and in a number of things related to the Nuclear Regulatory Commission. And that perspective has been really beneficial, I think, to X Energy. The reality is, every new nuclear product that's been delivered to the marketplace has typically been delivered in a joint effort between government and the private sector. And, I understand well what the government needs to achieve success. I understand well what companies like ours need from the government in order to achieve success. And I think that's made us uniquely effective over the last few years.
Can you talk about any specific regulatory or policy changes that you think would be most beneficial in advancing nuclear deployments in the U.S.?
The first thing I've got to say is the policy environment for new nuclear has been dramatically improved over the last 8 years. The previous Trump administration was very supportive of new nuclear. In fact, the first Trump administration created the Advanced Reactor Demonstration Program, which we are the beneficiary of. And the policy improvements continued in the current administration under President Biden. So, objective number one is to keep those policies in place. The loan authority that the Department of Energy has to finance nuclear power, that needs to stay in place. The investment tax credits and the production tax credits that were applied to nuclear power in the last 4 years, those policies need to stay in place and they need to be extended. The regulatory reform effort that has been underway at the NRC, with very strong backing from congressional leadership of both parties, that trend needs to continue. I think in terms of new policy, what the Congress and the administration really needs to focus on is the sustainability to get to great scale. When we stopped building nuclear plants, largely 40 years ago, a big part of our nuclear supply chain atrophied. Now, I will note, we've continued to build a few plants every year for the nuclear Navy, and that's an important part of the supply chain. But we need a much larger, much more robust supply chain in order to build the tens and tens of gigawatts of new nuclear power in the United States, over the next couple of decades. And so that's going to require sustained policy commitment to see us through and to get the entire nuclear enterprise to scale as quickly as possible.
Is X Energy pursuing anything outside of the U.S.? Do you have a pipeline of potential projects in Europe, for example?
We have a strategy at X Energy of today pursuing projects in 3 markets. Obviously, in our home market in the U.S., we're also pursuing projects in Canada in partnership with Ontario Power Gen, which is the largest nuclear operator in Canada. And we are pursuing projects in the United Kingdom as well. It's strategic that we chose those 3 markets. Those are 3 of the very top regulators in the world, the US, Canada, and the UK. And it's been our view that getting projects approved in even 2 of those 3 markets will basically allow us to take this design and certify it in any new market anywhere around the world based on the credibility and the quality of the regulators in the US, Canada, and the UK.
Even though I am a proponent of nuclear power, I have to maintain an open mind and consider the downsides. And one of the things that has traditionally hindered nuclear development is cost and schedule. It seems like projects very often are over budget and take many more years than people expect to get online. How do you respond to people's concerns when they talk about cost competitiveness of nuclear compared to renewables, for example?
Well, it's an inappropriate comparison, is what I tell them. It is inappropriate and makes no sense to compare a variable, non-dispatchable renewables to 24/7 carbon-free spinning reserves that you get from a nuclear power plant. It's comparing apples and milk cows. Right? That's what the comparison is like. And so you have to compare nuclear power to other clean, firm, 24/7, carbon-free sources of power. And in short, that's really kind of two other technologies that are widely scalable and deployable. The first of those is natural gas with carbon capture and sequestration. And the second of those is, blue hydrogen through turbo machinery to generate electricity. And both of those other technologies, present their unique challenges. But from a cost standpoint, as we have worked closely with our partners to evaluate how Generation 4 nuclear compares to those from a cost standpoint and from an executability standpoint, nuclear power has consistently been viewed as a preferable technology. And we have the wins to show for it. Dow is only interested in clean, firm, reliable power, and they'll get it from anywhere that they can. And they are pursuing carbon capture projects as well as blue hydrogen projects. But they're also pursuing new nuclear because of the benefits that they assess. The same is true with Amazon. When they chose our technology, they chose it because of the relative risks and the attractiveness associated with the technology.
Can you talk a little bit about how you intend to overcome the traditional cost and schedule problems that plants come up against? Is there a specific strategy that you have for your projects going forward to make them more timely and more budget sensitive?
Yes, Aaron, I mean, you have hit on the number one issue. The number one issue that has held nuclear power back in the United States and, quite frankly, in the Western world. And it is the historic inability of our industry to deliver projects on time and on budget. And everything about our strategy at X Energy from the beginning has been designed to address that number one issue. And so you can go back to every comment that we've made. We started with a meltdown proof reactor that could avail itself of a simpler design with fewer subsystems and components, less concrete, less steel. I mean, we just start with a design that on its face is easier to build. And then we take advantage of the ability to manufacture all of the components in a factory in a quality controlled environment and ship them to site for assembly rather than a stick built construction project that lasts decades, in the middle of the country somewhere. We have committed to not make the same mistakes that others that have gone before us have made. For example, we will not start construction of this plant with Dow until it is completely designed through advanced work packages and fabrication instructions to our supply chain, and it's completely well planned and ready to go. That's one of the major lessons of mega project success. We are also partnered for our first project with a company that has a long and well-established history in delivering large, complex mega projects as a part of its regular ongoing business. Dow builds mega projects. It's one of their core competencies. They have multiple mega projects under development at any given time. In fact, we're not even close to being the largest mega project that they have under development at Dow today. So there's a lot of expertise that is being applied to our project. There will always be problems and challenges on a first of a kind plant. That's just by nature. We know that there are problems and challenges on a first of a kind plant. The key is to quickly apply the lessons learned and replicate and repeat the effort and achieve scale and apply those lessons and get to an nth of a kind cost structure with a fully exercised supply chain up and running as quickly as possible. And that's what our partnership with Amazon gives us the best chance to do. Amazon, when they announced their investment in us in October, they also announced the investment into actual projects, first with Energy Northwest in Washington State, on the pathway to deploying 64 of our nuclear power modules in the next 15 years. And so by working in partnership first with Dow and then with Amazon, we believe we will be able to achieve all of the lessons learned, get to scale, and get to the lowest possible cost and eliminate the risk associated with first of a kind projects as quickly as possible. And we at X Energy have a better opportunity to do that than anyone currently in the market today, and quite frankly, anyone in the history of nuclear power deployments.
It does sound like a good strategy, so I hope you're successful with it, and I look forward to seeing some of these plants come online in the future.
We'll have you out for the ribbon cutting.
I would love that. That'll be great. Can you talk a little bit about what excites you the most about the future for nuclear technology? I mean, do you see this just really taking off and becoming mainstream around the country and around the world?
I do. We have an opportunity, the team at X Energy and our partners have an opportunity to allow the world to reimagine what clean, firm, 24/7 power looks like, what it feels like, and the availability that it can have to economies all around the globe. And when we imagine a future of a decarbonized economy with reliable power supporting dramatic growth at a reasonable cost, I believe X Energy is going to be a central technology to that future. So the opportunity to get to work on that every day is something that inspires me and everyone on the team at X Energy to keep pushing forward.
Again, for listeners, I've been speaking with Clay Sell. He is the CEO of X Energy. And Clay, I appreciate you taking the time to talk with us and share your insight. And we wish you well in getting your first plant online and more to come after that.
We'll see you at Seadrift, Texas in the next few years.